Well, this video is for Math 70. This is a follow-up on that first video about finding the equation of a line. So I'll run through a couple of these problems here. Let's see here. Let's start with problem 6. We've got the 2 points 1, 2, and 4, 17. Okay, so remember you've got the formula for the slope, y2 minus y1 over x2 minus x1, and the slope-intercept form, y equals mx plus b. So let's find the slope here. This is going to be 17 minus 2 on the top, and 4 minus 1 on the bottom. And so that gives us a slope of 5. So that says our equation is going to say y equals 5x plus b. And then we'll plug in the x and y coordinates here. So the y is 2 when the x is 1. So subtract 5 on both sides. B is negative 3. And so our answer here is y equals 5x minus 3. Let's see, does that make sense? If we go to 1, 2, and 4, 17, yeah, sure. Okay, it looks like we're going to get a y-intercept down here at negative 3, and that slope is pretty steep. Okay, the bigger this number is, the steeper that line is going to be. Alrighty, let's see here. What else? Let's look at problem 10. We've got negative 8 and 0.2 and negative 5, negative 1. Well, let's see what this looks like. Negative 8.2, negative 5, negative 1 is going to be something like that. So it says we should get a positive slope. Looks like it's going to be a pretty small number, should be less than 1 for our slope. And this says that our y-intercept b should be a positive number. Okay? Alright, so let's calculate this. Let's see here. I'll start with the 0.2 minus negative 1. Remember, this minus sign comes from the formula. This minus sign comes with the value of negative 1. Alright. I started with the 0.2 on top, I have to start with the minus 8 on the bottom, and again I get a double negative down there. So this will be 0.2 plus 1, negative 8 plus 5, so that's 1.2 over negative 3. There's a variety of things we can do to reduce this. Let's see what it does on a calculator. I think it's going to be just 0.4 then, negative 0.4. If we do 1.2 divided by negative 3, yeah, negative 0.4, and that's fine. You can use that as the slope. The other thing you can do is 12 over 30, right? Multiply both of these by 10, and then reduce it so that if we divide them both by 3, then we'll get 4 over 10, or negative 2/5. So you can use either one. It doesn't make any difference. Let's see. Now we need to know what is this b going to be. And, let's see it here. Okay. So here's the thing. Remember at the beginning I was saying that we should have a small positive slope. It should be climbing. But I didn't. I got a negative slope. Why is that? I graphed it wrong to begin with. I graphed negative 5, positive 1. That should be negative 5, negative 1. So let's correct that. So negative 8.2, negative 5, negative 1. So yeah, it's going to be something like that. And so that says that our y-intercept should be less than 0. Okay, so that's good to know. So let's go ahead and set this up. Y equals negative 0.4x plus b. And then we'll plug in our values. Y is 0.2 when x is negative 8. So let's see, 0.2 equals, what is that, positive 3.2 plus b. And then subtract 3.2 on both sides, and so this should be negative 3 for our b. So y equals negative 2/5 x minus 3. That's a good answer. Y is negative 0.4 x minus 3. That's also a good answer. Okay. All right, let's see what else we've got on this. Okay, let's see here. Let's look at problem 16. What do we have here? 5, 1, and 3, negative 3. So, let's see, 5, 1, 3, negative 3. Should be something like that. So it looks like we'll get a positive slope, but a negative y-intercept. Remember, the positive slopes go like this. The negative slopes go like this, right? The y is decreasing as the x's get bigger. That's a negative slope. Here the y is increasing as the x's get bigger. That's the positive slope. All right, so let's calculate the slope for this one. I'll start with the 1 minus double negative, negative 3, and then 5 minus 3. So this will be 1 plus 3 on top. 4 over 2 is 2. Okay, good. So y equals 2x plus b, and that's a positive slope. And then we'll plug in our values here. Y is negative 3 when the x is positive 3. And so then we get b equals negative 9. So our answer here should be y equals 2x minus 9, and that seems reasonable. All right, let's look at a couple more. Let's do problem 20. 112 and negative 3, negative 2. Let's see, 112, negative 3, negative 2, so something like that. So looks like we should get a positive slope and a positive y-intercept. Well, let's calculate here. I'll start with the 12 on top, minus negative 2, and then 1 minus negative 3. So this is 14 over 4, or 7 over 2. Okay? That looks reasonable. That is positive, so that's good. 7 over 2x plus b. So let's plug in our values. Y is 12 when x is 1. So, and I'll switch to a decimal here because I'm going to subtract. So b is going to be, what, 8.5? Yeah. Okay. Again, also positive. Good. So y equals 7 halves x plus 8.5. That's fine. You could use that 3.5 as well. That's fine too. They're both correct. All right. Let's just look at one more, since this is a follow-up assignment for something that we've already talked about. And then the next video we'll move on and look at something new. Problem 22. We've got the 0.75 and negative 212. All right. So let's calculate the slope here. I'll start with the 12 on top, so 12 minus 5, and then the negative 2 on the bottom, minus 7. And so on top, looks like we get 7, positive 7, and on the bottom, we get negative 9. Can't reduce it, that's just what we're going to work with. Okay? So y is equal to negative 7/9 x plus b. So, let's plug in our x and y values. The y is 5 when the x is 7. Alrighty, so this is negative 49 over 9, which doesn't reduce. And so we've just got to add 49 over 9 to both sides. So what is b going to end up being here? 5 plus 49 over 9, yeah, use a calculator, whatever you want to do. I'm going to, let's see, 5 over 1 is going to be 45 over 9, and then we got to add 49 over 9 to that, so that's going to give us 94 over 9. Okay, so y equals negative 7/9 x plus 94 over 9, which is 10.4 repeating, or 10 4/9. Okay? Now, if you wanted to do this with decimals, there's nothing wrong with that. But you should understand how repeating decimals work, right? If you want to turn this into a decimal, do 7 divided by 9, and you'll get negative 0.7 repeating, okay? Now, if you want to calculate with that number, take the calculator, whatever calculator it is that you're using, and then just type in that 7 a whole bunch of times, 0.77777. And then we're going to multiply that by 7. And then we got to add that to the 5. And there's our 10.4 repeating. And that's what I got over there. See, if you do that 94 divided by 9, there's that 10.4 repeating. Okay? So, there's nothing wrong with switching to decimals, so long as you do it in an intelligent way. All right? So, like I said, we've already talked about this in one previous assignment, so this is just a follow-up assignment to practice a little bit. I'll post a quiz along with this, and then, like I said, we'll do the next assignment. We'll move on and look at something new. We'll talk about parallel, and perpendicular lines. As always, if you have any questions, please let me know. Thanks.